Hello students, in this session let us discuss about the operation and testing of a GM counter. A radioactive source is placed in a fixed position at a suitable distance from the counter. The applied voltage is gradually increased. When the applied voltage is low, the counting rate will be 0. As the applied potential is raised, maximum ionization is produced in the counter and we start getting the counts. At a certain value of applied voltage, the number of pulses increases almost linearly with the voltage. This is the proportional counter reason. Next, what happens? The Geiger reason is reached when the pulses due to all the ionization particles are recorded and these also have the same height. This operating potential is called the Geiger threshold of the counter under the given conditions. Now, when the voltage is increased beyond the threshold, the counting rate remains the same for a large increase in voltage, but the pulse height rises. This portion of the graph between the counting rate and applied potential is therefore a straight line, and this is known as the plateau region of the GM characteristic curve. Next one is the applications of GM counter. So GM counters are very useful for detecting nuclear radiations and charged particles. It is being largely used for measuring cosmic ray intensities and recording cosmic ray events. The counter setup with transistorized electronics is very light and portable. It serves best for mineral prospecting and other similar work. So if we see the advantages of GM counter, so the GM counters are very useful for detecting the nuclear particles like alpha and beta particles and protons, for measuring cosmic ray intensities and recording cosmic ray events. They are sensitive to production of even a single ion pair. The pulse height is sufficiently high, which requires a little of amplification. The pulse size is independent of the nature and energy of the incident ionizing particle or radiation. The pulse height is constant over a wide range of applied voltage, that is known as the plateau width, so that the power supply need not be precisely regulated as required in the proportional counter. The counter setup with transistorized electronics is light and portable and can be used for mineral prospecting and cosmic ray works. So these are all the advantages of GM tube. Now what are the disadvantages of GM tube? Let us see. So the disadvantages are, it prevents the use at very high counting rates of about 10 to the power of 4 particles per second because of the large dead time and recovery time. GM counters have very low intrinsic efficiency for detecting gamma radiations. They cannot detect uncharged particles like neutrons. GM tubes have a limited life as the quenching gases dissociate and change the pressure of the inert gas filled in it. It cannot provide information regarding the nature of the ionizing particle or even whether it is a charged particle or a photon. So these are all some of the disadvantages of the GM counter. Next, so what we have learned, students, in this session we have learnt about the characteristic of the GM counter, in which we came to know about the different reasons of the GM counter characteristic curve. So we have also learned what are the uses of GM counter, what are the advantages and limitations of the GM counter. Thank you. things.